Hi guys, it's AJ here again, and today I want to make another little spin-off series about why this basically inverse sign changed the binary number from a negative to a positive. Well, basically I've been teaching you guys about the integer, but I have been leaving something out for simplicity's sake, and I guess it's better if I explain it now. There was also a keyword in C that is signed or an unsigned integer. Now, what do these things mean? Unsigned means that it doesn't have a sign. It only can be 0 to a positive number. Signed means it can have a sign, so it can be negative or positive. It's a little confusing, so I'll say it again, but I always have to think about it a little too. So signed means you can have both sides of the sword. You can be negative or positive because it's signed. And unsigned means it can only have 0 to a positive number. And so both of these signed and unsigned representations are different in binary. And the way I like to think about it is that, let's say I have a signed integer of 1010. And let me just comment below it. I want the numbers that correspond to that in binary are 1. So under the 0 responds to a 1. So if I add that up, a 2, which is just 2 to the 0 for the 1, 2 to the first power for the 2, and 2 to the second power for the third digit, and 2 to the third power for the fourth digit. But in signed binary, that this actually refers, the last bit, the leftmost bit, refers to a negative number. So whatever power it is to, it's the negative of that. So this is a -8. And what this allows me to do is that if I had 1 0 0 0, it would just be -8. And so if I add these up, I actually get -6. Because it's 2 plus the -8. Now, something here to always point out, even though I don't have it explicitly said, numbers automatically default to unsigned. So, as I showed you before, I can make this negative. That's because it's automatically unsigned. But I don't even have to put that to tell the compiler, which reads all your code and puts its machine language, that it is unsigned. Now, if I wanted to tell the compiler that it is signed, I would have to tell that. It doesn't know that because it defaults to unsigned. And that's okay. You don't have to write unsigned if you're using an unsigned integer, but if you only want to use signed, you definitely want to put it there so the compiler knows. Now again, if it's just if it's a signed number, it can only be positive. So the last bit will not register a negative number. And as you can see here, what's so important about this for the signed bits, is that the maximum negative number we can reach is -8, which would be 1 0 0 0, and the maximum positive digit we can make is 0 1 1 1, which would be 7. So and this is a rule, you can always, the maximum of the negative numbers on the other side, you can only reach -1 of what the negative maximum is, if that makes sense. So as you can see here, as I said again, the minimum, as I should say, is -8, and the maximum is you take that number, flip it, or get rid of the sign, and minus it by 1 on the positive side. So the maximum is 7 for positive, and this would be true if I increase the number of bits to 16 or 32 or whatever. And so this is what's happening when I throw in this symbol, is that it's flipping that negative bit, and it's causing that change, that asymmetrical change, to happen in the bits. It's causing that non-symmetrical difference of when I put in the 1 to be different. So for instance, I know integers are 32 bits. That means there's a 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. I just put them in 4s to make it easier. let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, that's 36, so that's, okay, so that's 32. And all the way at the leftmost bit, your machine defines integers in certain ways. And so I know my machine defines it in 32 ways. And since this is a modern computing era, you really don't have to worry about that. But it's good to just know everything. And so if I just did this, this would be negative 2 to the 31st power, because remember, this represents 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, all the way to 2 to the 31st. So if I say, hey, this is this is a 32-bit integer, that means that the leftmost bit is going to be 2 to the 31st power, because you're also counting 0. So that's kind of -1 on the maximum side, if you understand that better. So this would be the maximum negative number that's possible, because all these other numbers represent positive numbers, and so I would just be adding those together. Yeah, so let's say, if I have this 8 here, let's see, that's going to be, I'm going to make this 0 again. 8 is going to be, I believe, 1, 2, 4. It's just going to put a 1 right there, but all these zeros are still going to exist for when I flip it. And so obviously when I put the flip here, it's going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, because I'm flipping all the zeros. But there's a rule here that I want to show you guys, and that is that when, or a little trick, when you let me just do it this way. Yeah, I didn't flip those last digits. When you are flipping a signed integer, you want to flip all the bits and then stop at the rightmost one. So you want to flip all the bits to the left of the rightmost one. So as you can see, this is the rightmost one. So I'm going to flip everything to whatever it needs to be to the left of it. But then when I get to the rightmost one, I'm just going to stop there. And what that does is, that's kind of a simple trick, but what I'm doing here is to make up for the asymmetricalness is I'm flipping all the bits. Let's say if I flipped all the bits, so this would work too, I would add like that. That is exactly flipping all the bits. I would then have to add 1 to make up for the asymmetricalness, that the range, for instance, here is from -8 to 7. I would add 1, so this would be, so the first digit would become 0 because I'd be adding 1, and you'd carry 1 over here, and then that would make it 0. And then carrying 1 over here again would make it 0, and then this would finally be left with just 1, which is just what I showed you. But that's another way to do it, is you flip all the digits and add 1 and make sure you carry over, because the same result will happen no matter what. I just showed you a shortcut. So as you can see, I flipped all these up. I'm not going to take the time to add this all up, but if you add this all up, I believe you would get -9, which, as you can see as I run this, shows up as -9. Now let me show you, I guess I will make this unsigned and see what happens. I believe it will not print out, it will still print out -9 because, yes, so I told you unsigned means that what I told you last time is that, again, unsigned integers can only have 0 to 1 values. And as you can see, well, don't look at that printing from when I cut, is that it still prints out a negative number. But you said, gee, AJ, unsigned integers can only be 0 to 9. Well, or 0 to a very big positive number. And in this case, with 32 bits, the highest possible number can be is 2 to the 32nd minus 1. I believe I have another video on hexadecimal and decimal numbers if you want to look more into the maximum and minimum of numbers, or just Google it. It's all about the free knowledge here. And what was I going to say? So, as you can see, I printed out 8 with a unsigned integer, and I still got -9, which shouldn't be the case. There should be, in the unsigned integer, there's no negative. The last bit is not a negative bit because it's all positive. There's no way to make it negative. So actually, the reason because it's printing out a unsigned integer is because or assigned integer last time is because the printf statement converts it to a signed integer and then prints it out, which is bad. So the %d would always print out a signed integer. It will convert it to a signed integer, but you will not convert it to an unsigned integer. And as we see when we print it out, we get a very huge number, as I just tested, because I wanted to make sure I gave you guys the right answer. So make sure you do that. You can look up printf statements and everything they do. For instance, let me show you, I guess another quick one is that if I do x, it prints it out in hexadecimal, which I'm not sure you know, but hexadecimal is just base 10 instead of base hexadecimal is base 16. Base 16 instead of the base 10, which is regular numbers, decimal numbers, and binary, which is regular numbers, of which you know. Okay, guys, this video is running pretty long, and I hope you guys enjoyed this tutorial. See you later.